Hello everyone and welcome to our weekly studio review. It's Friday, which means it's the end of another week of the semester, and we had our first official studio this past week, Studio 1, so this was actually the very first thing that counted for credit in the entire course. So hopefully you were able to make it and get through the studio okay. If you didn't, well, that's what this video is for. I'm going to go through the studio exercises, and then at the end of the studio, I'm going to talk a little bit about the upcoming homework assignment. So let's go ahead and dive right in. Starting with High 1, I've already got the code loaded into Eclipse. I didn't want to spend time during the video doing all that stuff. So here you can see I've got Studio 1 loaded up, and here is High 1. Give me just a moment here to zoom in on that text so that we can actually read it. I don't mind doing this on video because this is actually not a bad thing for you to see and know how to do yourself should you want to change the font size on your own machine. There we go. That's a little bit easier to see. Okay, so you've been given some code right up here at the beginning of the program. We know it's the beginning of the program, again, because we see that magical word main, so that's the starting point. First thing we're doing is creating a scanner, and recall from the exercises that scanner is how we grab user input. So we're asking, enter a value for arg0, and that's a little silly. We don't necessarily want to say enter a value for arg0. We'd rather say something more specific to what we want them to do so they actually know what to type. Right? Imagine giving this to your mom or your brother or something. They're not going to know what arg0 is, so let's say something a little bit more friendly like enter your name. So we use a print statement. After the print statement, we're going to use the scanner right here by saying in.nextLine, and that will read in whatever the user types into the keyboard. And we can actually run the program at this point, and I can show you that that in fact happens. But here we go. I'll go ahead and type in my name, Doug. When I hit enter, it doesn't do anything after that. And so that's kind of the next step, is to say hello to whatever name got entered in. So let's go ahead and do that next. We're going to need a print statement. I'll use print ln, although I guess using print it may make a difference. You'd have to try it and see, I suppose. We want to type the word hello, and then we want to tack the name on the end of this string. So you could do this in two steps. You could go down to the next line and say, another print statement for the name, or if you wanted to do it all in one, you can use something called concatenation. And concatenation is the act of taking two strings, or actually it doesn't have to be two strings. In this case, that's what it is. But it's taking a string and something else and just kind of tacking them together and making a bigger string that contains all of that information. That's the act of concatenation. And that's an important thing to know because, again, like I explained during the first lecture session in class, the computer, when it looks at this sign, maybe it's addition, but in order to make that determination, it's going to examine the types of the things that are involved. And so here we can tell this is very clearly a string just due to the presence of quotations. For the variable name, we can also tell it's a string because that's how the variable was declared. So here's the variable declaration. Variable declaration consists of two parts: the type, which is given as a string, and then the name of the variable, which in this case happens to be name. So if we try this code again with the concatenated values on, added on to the end of the program, I'm going to run it again, and this time when I type in my name, it'll say hello to me. And if I wanted to, I could even add some punctuation to the end, like an exclamation point, like so. Let's try that one more time. This time I'll say my son's name, Simon. Hello, Simon. Great. I think that's going to wrap it up for that one. Let's move on to the next exercise for us. This time we're going to do the same kind of idea, but we want to say hello to 4 people, and we need to use proper punctuation. So let's go ahead and take a look at how to accomplish this by opening up the High 4. Here you can see sort of a similar setup. We create the scanner for you. We have print statements that ask for, okay, I don't want to do this. I want to say name 1, and then name 2, etc., so that people who are using this code actually know what they need to type in. And just like we saw with the prior statement, I would prefer to do this all in one line. You could break this up, and use multiple lines to print this out. But using string concatenation, we can actually do this all in one line. So let me show you how that might work. I'll tack on S0, which is my first name, using concatenation. And then I need to put a comma in between, so I'm going to concatenate that comma on like so, by putting a comma and a space in between these quotes, right? And actually, I'm going to go ahead and stop right here and see what this looks like. Run the program. All right, I have to enter the name John, Paul, George, and Ringo. And so I didn't do them all yet, but it says, hello, John. All right, so I need to keep going. I need to add on S1, followed by a comma. I need to add on S2, followed by a comma. And then S3 doesn't need a comma after it because it is the final name of our program. And you can see that I've made a mistake. I went a little bit too quickly. You can see Eclipse is unhappy at me. Maybe you've already figured out what the mistake is that I made. Maybe you saw me do it. If I hover over this, it says the operator plus is undefined for the type string. That's actually not particularly helpful. This just says delete S2, and that seems a little bit confusing. So it takes a little bit of understanding about what's going on here, right? I see that I've got this quotes and I've got this string. I forgot the plus sign in between. So once I fix that, and I added an additional comma here as well, so I actually made two mistakes. Interesting. But Eclipse pointed out that the mistakes were there. Somehow I got an extra parenthesis and semicolon at the end of the line as well, making all kinds of mistakes. That's okay. Programming is about making mistakes and then fixing them. So now that I've fixed up my syntax errors, let's see if we can run this program and say hello to these people. I'm going to type in John, Paul, George, and Ringo. Hello, John, Paul, George, Ringo. The only thing that I may be forgetting is a period or exclamation point at the end of our statement here. So I'll go ahead and add that on, maybe run it one more time. There we go. Looks good. Proper punctuation and all. Okay, now that that one's finished, we're going to move on to the next one. This time we're going to look at the ordered example. And let's take a look at the code that's been provided for us. It looks like this time we're not dealing with strings, but we're dealing with ints. And I can tell that in a couple of different ways. I can see that I'm creating 3 different integer variables, x, y, and z. I can also see that when I use the scanner, it says in.nextInt. It doesn't say in.nextLine like we were using for strings. So let's take a look at the instructions and see what else is going on here. It says define a Boolean variable is ordered whose value is true if the 3 values are either in strictly ascending order, or in strictly descending order, and false otherwise. So x is less than y is less than z, or x is greater than y is greater than z. You are going to need a little bit of an additional tool to help you out here. And in order to explain why we need that tool, let me go ahead and try to set this up in a way that I see lots of people attempt this. X is less than y is less than z, right? This is a very common approach that people will take. And you can see that Eclipse is not happy about this. It does not like it. And the reason for that is that when we use an operation like this, less than or greater than or anything like that, it can only work with 2 and exactly 2 things. So it's going to look at this and it's going to say x is less than y. That's either going to be true or false. It's then going to substitute that value in and keep going. So it's going to be either true or false is less than z. What does that mean? What does it mean for true to be less than z? That's not really a thing that makes sense, right? What you meant is x is less than y and y is less than z. Did you notice the way that I stated that out loud? We can actually say a similar kind of statement in our code. So x is less than y and, notice that there's 2 of them, y is less than z. Here we go. So now you can see the syntax error has gone away, but let's make sure we understand why this is happening. This will be true if both this is true and this thing is true. If either one of these sides is false, then this will be false. And I'm actually going to change the name of this because is ordered isn't quite what we want. I'm going to call this ascending because the numbers go up, right? So we're saying x must be less than y and y must be less than z. If both of those things are true, then we know that the numbers are ascending. You could consider that I could write a similar statement to check for descending numbers, and I would probably just flip the sign, right? I would just do the same thing and flip the sign to say greater than instead of less than, and that would actually be just fine. I don't see a problem with doing that at all. What we need to do is determine if either of those things are true. So we want to declare this variable is ordered that's true if this is true or if this is true. And so just like we saw with and, we also have a way of saying or in our code as well. These are what's known as compound operators, and you're going to learn more about compound operators when you go through the prep work for the exercises for Module 2 this week. We'll talk about that in Module 2. But to kind of wrap this up here, we can see Boolean is ordered. So I know they're ordered if this one is true or if this one is true. And in order to say that in my code, I can say ascending or descending. So I know this doesn't look quite like the word, maybe what you were expecting. This character is called a pipe, and it is above your enter key. It's a straight vertical line. It's called a pipe. And again, just like we saw with the and sign, we need two of them. So two ands and two pipes specify or. Let's go ahead and try this in a few different ways. And what I actually want to do is run this through the debugger and take a look at these operations in a little bit more detail. So I set my breakpoint on line 19. I'm going to try this in a few different ways and see what happens. So first, let's try values that are ascending. So I'll say something simple like 3, 4, and 5. And let's switch over to our debug mode. So recall that for and to be true, for this value to be true, both the left-hand side and the right-hand side must be true. So x less than y is going to be true. Y less than z is also going to be true. So when we look at the left-hand side, it's going to say true and true, which means that the ascending variable will have a value of true. And I can see that here. For the descending variable, it's going to look at this and say, all right, x greater than y, that is false. And actually, at this point, we already know what our answer is. We don't even have to look at this, because if either side of the and operation is false, then I know that the answer is going to be false. So because this is false, I know that descending is going to be false. Actually, this side is also false, so it's kind of extra, super, double false. But we don't even need to look at that to make that determination. If I continue stepping through the code, we'll see that, okay, descending is false. But for this last one, right, only one side or the other side has to be true. So this is an or operation, not an and operation. So if ascending is true, then is ordered will be true. If descending is true, then is ordered will be true. I can see that ascending is true and descending is false. So if I step through one more time, we'll see that the value of is ordered turns out to be true. They are ordered. They are in ascending order, but not descending order, and that's okay. Let's stop this program, and I'm actually going to try it again. This time I want to see, descending order. So let's go 5, 4, 3. This time we're doing descending order. I'll go a little quicker this time. I can see that ascending is false. That's what I would expect. Descending this time is in fact true. And again, or only requires one side or the other to be true. So because descending is true, is ordered is also true, right? There's actually one more situation that I would like to check to make sure that it works. Let's run through this example one more time, and this time we're going to do one that's not ordered at all. So I'm going to type in, like 6, 2, 9. Okay? So if I look at ascending, it's going to say x is less than y. That's false. So we already know that ascending should be false. All right, I look at descending, x is greater than y. That's true. But y greater than z, that's actually false. And so because this side is false, the entire expression over here is going to be false. If I step forward, we'll see that, okay, both ascending and descending are false. Now for this final expression, since this side is false and this side is false, the or statement is going to be false as well. Remember, an or statement needs either one side or the other to be true in order to give back a true statement. So here we see is ordered is false. And those are all three possible paths through our code, right? Ascending, descending, and is ordered. not ordered at all, rather. Alrighty. I believe that wraps it up for this example. Let's go on to, I think we've got just, we've got just a couple left to do here. The next one is called average, and we're going to have you make this one yourself this time. So let me get out of debug mode real quick, go back to the Java perspective, and I'm going to make a new class for this one by right-clicking the package. Package is really just kind of like a folder. So I right-click on this package and I say new class. I want to call it average. And I also am going to check this box right here to put in my main. There's those magic words that we've seen in the other programs as well. So I'm going to check that box. And here we have a blank Java file that is ready for us to start doing some work. So let's see what we need to do. It's asking us to insert the scanner code to accept two integers, n1 and n2, and then we want to print out the average of those two integers. So you can see that the result of that average could be a not integer, right? It could actually be a double, so we need to take that into account. So let's set up our scanner first. Now, I actually know how to set up the scanner. I've done it enough times, but you haven't done it that many times yet. So I hope what you did is you went back to one of the prior examples and grabbed some of this code. Which is what I'm going to do. I'm going to grab this line right here and just paste it in. You can see that Eclipse added this import up at the top for me, which is great. I'm going to go ahead and read in my integer values next. Oh, I forgot a step though. I need to write out a prompt. Please enter a value to be averaged. We'll try something like that. Got some junk over here to get rid of. There we go. Now I can read in the integer using in.nextInt. And now we need to read in the second value. So I'm actually just going to copy these two lines and tweak them a little bit, right? I'll call the next value n2. Please enter another value to be averaged, right? Okay. Now we need to do the actual arithmetic. So we saw that the result could be a double. The average of 5 and 6 would be 5.5, and that makes sense to me. In order to compute the average, we'll go ahead and add those two together, and then divide by 2. So let's run this code and see what happens. I'll try the example that we saw. I'll try 5 and 6. And whoops, I made a mistake, which I kind of knew I made a mistake. I didn't actually print out the result. I computed it, but I never actually printed it. So let's go ahead and print out what we print out our average variable so we can actually see the results. All right, try this again. 5 and 6 gives us 8. 8. That doesn't seem right. It should be 5.5. What the heck happened? Well, let's go back and take a look at our math. It seems like there might be a problem with our math. In fact, there is. If we look at this right here, we can see that it says n plus 1, m1 plus n2 over 2. We didn't factor in the order of operations. So order of operations says this division operation is going to happen before this addition operation does, but that's not how averaging works. We need to average these two things together first. So using parentheses is necessary to make sure that addition statement happens first. Let's try it again and see if that fixes the value for us. 5 and 6. This time we got 5. All right, so we're closer, but still not quite the value that we expected. To understand what happened this time, consider that the result that we get depends on the operation that we're performing and the types that are involved. So I look at this division operation that's happening, and I see the things that on this side is going to be an int, right? An int plus an int is going to give me an int back. So the left side is an integer, the right-hand side is an integer. An integer divided by an integer is also going to be an integer. So it actually could probably determine that it was 5.5, but since it's going to give me an integer back, it can't give me 5.5. It does the next best thing, which is chops that decimal off. Notice it doesn't even round it up to 6. It just chops it off. We call it truncation, right? And gives me the value of 5. So in order to actually get the value that we want, we need to make sure that either the left-hand side or the right-hand side is a double. I think the easiest way to do that would be to make the 2 a double by adding a .0 after it. let's try this one more time and see if that gets us where we want to be. There we go. There's our 5.5. Yep, seems to be working properly. Of course, in order to really know that it's working properly, you want to try this with a few different values. You wouldn't just want to try it with one set of values, but try a few different ones. Make sure it still works. All right, I believe there is one final exercise for us to code up here called leap year. So we're going to determine if something is a leap year, and the rules for determining a leap year are given here. A value is a leap year if it is evenly divisible by 4, if it is not evenly divisible by 100, and if it is evenly divisible by 400, then, well, we have to make an exception for that rule. So this sounds like a lot, but like most problems, we're going to break it into chunks. So let's just focus on the first one, right? Let's just focus on the first part. Actually, before we even get to this part, we have to set up our scanner. So we have to make a leap year class, and we have to set up the scanner. So let's go ahead and do that first. I'm going to right-click the package, go to New Class. I'm going to say leap year here in the box, and I'm going to check the box to create my main for me. Alrighty. I don't like having this junk here, so I usually take it out. This time I'll just type in scanner in equals new scanner system.in. If you copy paste that from another file, that is totally 100% okay. The next thing we need to do is prompt them. Please enter a year. And now we can use our scanner to read in a year, which is probably going to be an integer, right? Int year is equal to in.nextInt. All right. Now we just have to decide if this value is divisible by 4. That is our first criteria, right? That is our first criteria. So let's go ahead and see if we can make that determination. Either a value is divisible by 4 or it's not. I saw some people trying to do if statements here, which we haven't covered those yet. It's not technically wrong to use if statements here, but it's also not necessary. And I would encourage you to think about, solving things without if statements when they're not explicitly necessary, as in this situation. So what we can do instead is say, is divisible by 4 as a Boolean, and we'll just compute that. In order to compute that, we need to use something called the modulus operator. So what I'm going to do is I'm going to say year %, or the way I would say that actually is modulus 4. And what this does is it gives me back the remainder after division. So if the year I typed in was 7, this would give me back 3, because 7 divided by 4 is 1 with a remainder of 3. If I typed in 15, right, it would also give me 3, because 15 divided by 4 is 3 with 3 remaining. 3 is the remainder. So what I want to know, if something is evenly divisible by 4, that means that 4 goes into this value without a remainder, or the remainder is 0. So I might say something like, if the year divided by 4, if the modulus, right, the remainder after divided by 4 is equal to 0, I know it must be divisible by 4. And I made a very common mistake here. You'll see that in order to check to see this, I used a single equals, which kind of makes sense, right? But remember, in coding, single equals is how we do variable assignment. So when I see a single equals, that means evaluate the thing on the right-hand side and put it in the variable on the left-hand side. And that's not really what we're doing here. What we're doing here is trying to check for equality. So we're asking, is the thing on the left equal to the thing on the right? And in order to determine quality in our Java programs, we need to use 2 equal signs. So the way to think about this, right, if I look at this, it'll say year divided by 4 is the remainder 0. That's either going to be true or false. Whatever it is, it's going to get stored into this variable here. So that's just one part of it, and we should actually test this. I'm going to go ahead and do a print statement here just to test, make sure that this is working. We'll type in a few values, some that are divisible by 4 and some that aren't. So like the year 16, for example, is divisible by 4, right? But the year 15 is not. Okay. The year 2020 is divisible by 4, right? but the year 2021 is not divisible by 4. Okay, but that's only part of the problem, so we have to do some more checks. The next check is to see if it's not evenly divisible by 100. So I'm going to make another Boolean variable for that one. Is not divisible by 100. And we'll use a similar process. I'll say year modulus 100, and this time I want to say is not equal to 0. If there is a remainder left over, then that means 100 does not go in evenly. In order to say not equal to, we use the exclamation point. So exclamation point typically means not. I'll often read it that way. Not equal to 0. So what this will do, right, is check to see if 100 goes in evenly. If there's a remainder left over, that means it's not equal to 0. That means that this is going to be true. Let's test this out. Right? Let's test this out. So if I enter a value that's I need to put a print statement in before I test this out. Sorry about that. So, 100 is divisible by 100, so this is false, right? 150 is not evenly divisible by 100, so we can see that true gets printed out. True means that it is not divisible by 100. That's what we're checking for. I know the logic can feel a little hard to follow, especially if you're not used to solving problems like this, right? That's why I've tried to name my variables carefully, exactly what they represent to help me understand. All right, I think we're almost there. We just have one final thing to do. An exception to this rule is if the year is evenly divisible by 400. So these years are leap years. So let's make one more variable for is divisible by 400, and then we just need to tie it all together. That's actually going to look very similar to what we have up here, except instead of saying 4, I'm going to say 400. All right. I'm not going to run through the next, I'm not going to print that one out. I'm just going to move on to the next and final step, which is to try and tie this all together. So I know something is a leap year if it is divisible by 400. Those years are leap years. It says right here. So if it's divisible by 400, you're a leap year. Or if it is evenly divisible by 4 and it is not evenly divisible by 100, it is also a leap year. So how would I say that in practice? I'm going to make one final variable, is leap year. I know it's a leap year if it is divisible by 400. It's automatically a leap year if that's true. So if this is true, it must be a leap year. Or notice the parentheses that I'm putting in here. Is divisible by 4 and is not divisible by 100. I misspelled this variable. That's why Eclipse got mad at me there. Oh, I still misspelled it. There we go. All right, finally got it. So I use these parentheses very intentionally here, right? Think about what this is saying. Either the leap year is divisible by 4 and not divisible by 100, so both of those things must be true, or the leap year is divisible by 400. And if you still are kind of having a hard time, following along with my logic here, understanding how this code works, I would suggest a few things for you to do next. One would be to use the debugger and step through this code, but also we need to test this. So I'm going to put in one more print statement down here. The studio instructions gave you examples of all the different categories. So 2020 is a leap year because it's evenly divisible by 4. 1900 is evenly divisible by 4, but since it's also divisible by 100, it is not a leap year. And 2000 is evenly divisible by 4 and 100, but because it's also divisible by 400, it is a leap year. So let's try all three of these conditions. 2020 should be a leap year. That's a very just straightforward divisible by 4. Let's run the program. Please enter a year, 2020. True, that one is a leap year, okay. 1900 is divisible by 4, but it's also evenly divisible by 100, so it is not a leap year. Let's go ahead and try that one. 1900, false, not a leap year. All right. 2000 is divisible by 4 and 100, but it's also divisible by 400, so it is a leap year. Let's try that one. 2000. True, that one is a leap year. I believe this code is functioning properly. You don't have to take my word for it. You should definitely try some more examples, and definitely try stepping through this code using the debugger if you don't understand how it works. Okay. There is one final non-coding exercise down here. Just kind of thinking about, how does this apply in a general case? Well, every program we write, we are responsible for choosing appropriate types for the variables that are represented in our program. So, some things are going to make more sense to be represented as strings, and other things will make more sense to be represented as ints, and it's up to us as the programmers to make those distinctions and decide on the types of the variables that we're using in our program. So this is just a little creative thought exercise for you to think about what types of variables you would use. We've only actually seen 4 types so far, and I think all of these fall into one of those 4 categories. But just to do the first one real quick, the number of times you've been to Ted Drew's clearly should be numeric. But remember, we have two different numeric types. In this case, the integer type makes more sense because how do you go to Ted Drew's for 2/3 of a time? That's not something we typically track. So int makes the most sense here as opposed to double. All right. The final thing that I wanted to go over as part of this video is the assignment. So assignment 1 is going to be due in your lab section next week on Wednesday or Thursday, depending on which section you're registered for. We're asking you to make a grade calculator, and this is very much based on the grades that you'll be earning in this class. So we're asking you to make a program that's going to accept inputs from the user for all of these different values. I want to make a point to note that we're asking you to type in the average assignment grade. We are not asking you to type in your grade for every single assignment. Same thing for the the quizzes and the exams. We're not asking you to type in your grade for every quiz. We're just asking you to type in your average quiz grade. Could you make a program that asks you to type in every assignment and every quiz and computes your grade that way? Yes, you could. We just thought that would be a little bit tedious. So we trying to keep this assignment from getting too big and taking up too much of your time by just asking for the averages to be typed in, right? So once you acquire these values from your user using the scanner, you're going to use the scanner to read in these 5 values, you're going to compute the grades. So you'll compute the weighted grades and the total grades based on the values that were typed in. So the instructions go into a little bit more detail about what you should be doing for this, but what I really want to draw your attention to is down here at the bottom. For every assignment in this class, there is a posted rubric, and this rubric is how your assignment will be graded. So the way that it works, you've already seen this if you demoed assignment 0 in class this past week, but when you come to class next week to turn in assignment 1, you're going to get a TA to come around, and they are going to walk you through the rubric. Literally just going to pull up the rubric on Canvas and walk you through this step by step. And so you should go through this ahead of time. You should prepare. You should look at the rubric and make sure you understand exactly what's going to happen. Some of these involve the TA asking you direct questions. So here you can see this says the student can explain what data type was chosen for total studios attended and why. You should have an answer for that. It should not be a surprise. Think about this ahead of time and be prepared for it. Write it down. Make comments in your code. Whatever will help you out. Student can identify a line where scanner is used to read in a double. This should not be a surprise. This should not be something that you're doing like on the fly. Be prepared for this. Find that line, in the code ahead of time. Mark it with a comment. Write down the line number so that when the TA says, hey, show me a line where you're using scanner to read in a double, you can just point directly. That's literally all you have to do. You just have to point directly to it. Say, here's that line right here. Line 27, or whatever the line is. Okay? So the rubric is really kind of giving you a big clue as to what we're looking for when you submit the assignment You should definitely take a look at this rubric ahead of time and definitely use it to help you prepare for the assignment demos. Okay? I believe that's going to do it for now. For Monday, I'll be going over the material from Module 2, so I will see you then.